Hi, this is Mrs. May. Today we're going to talk about solving inequalities, which is related to lessons 6-1 and 6-2. Solving inequalities with adding and subtracting. An inequality is the signs that you typically see. You're less than, greater than, less than or equal to, greater than or equal to. I would take a minute just to make yourself a note that an inequality means it is not equal, although sometimes it can be equal. In this case, we've got writing the inequality represented by x is less than 3. So we're going to do that graphing it on a number line. So as we're looking at this number line, notice this is positive 3. And I would draw an open circle around the 3 on the number line. And it says x is less than 3. So anything less than 3 is going to be part of my solution set. So I would draw a line indicating that this inequality x is less than 3. Notice I circled it with an open circle for the 3. That's because it is not equal to 3, but it is equal to anything less than 3, or any data that's less than 3 is part of that solution set. When looking at and graphing this equation or inequality, we've got x minus 5 is greater than a negative 3 and 5/10. What I'm going to do is rewrite this on the other side of the board here, because we need to get x by itself. Just like when we were solving other equations, we need to worry about getting x by itself. Because this is a negative 5, or you're subtracting 5. We want the opposite of that, which is a positive 5, or thinking of it as adding 5 to both sides. This is going to leave x by itself, and we have a greater than sign that we move down, and negative 3.5 plus 5 is a positive 1 and 5/10. So when we go to graph this, notice that my number line does not have a 1 and 5/10, but we're going to circle right in that area there because we're just creating a graph. And remember, a graph isn't always specific. You could write underneath here 1 and 5/10, and then x is greater than that. Notice again I have an open circle, and I draw my arrow to the right because the information is greater than that, or the solution set is greater than that. And it doesn't say equal to, so we have to leave that as an open circle because it doesn't include that. I want to pause this for a minute. There's some good information here. There is a rule, a special rule when solving inequalities that states if you flip the inequality sign when you multiply or divide by a negative number to isolate the variable, not if side without the variable already is negative. So let me do a couple of examples here. On the first one, we've got x divided by 3 is greater than 8. So we're going to go about solving this. I'm sorry about that. Let me erase that. Didn't mean to do that. I just meant to move my board up a little bit here. There we go. We've got x divided by 3 is greater than 8. So the opposite of dividing by 3 is to multiply by 3. So we are going to want to multiply by 3 on both sides of the equation, meaning we now have x alone by itself is greater than 24. Now notice I have a different set of number lines here. I didn't put the numbers on those because you actually would want to draw your own number lines. And I would highly recommend that you have at least 5 numbers on your number line. It's very difficult to write on my screen, but I'm sure in your notes it's much easier. And it says x is greater than 24, so you're going to circle the 24. It's not equal to that, so you've got to have an open circle. X is greater than that, so we're going to go to the right. So the solution set for this problem is x is greater than 24. The next problem we have m divided by 8 is less than or equal to negative 2. Notice there is no negative sign here, so we don't have to worry about that, but we do want to multiply both sides by 8. It's going to leave us m is less than or equal to a negative 2 times 8, which is negative 16. I want to go back up to this original side note here. It says to flip the inequality sign when multiplying or dividing by a negative number to isolate the variable. Notice that we are not multiplying or dividing by a negative number. We are multiplying by a positive number. So it's okay. We don't have to flip the sign yet. So we've got m is less than or equal to negative 16. So when I draw my number line, again, I would want to see if I can do this right on my number line. I would want to include at least 5 numbers on my number line. So notice this time it says here that it is less than or equal to negative 16. So now this time I would want to color in that circle. That means that it includes negative 16, and then it is less than that. So I would want my arrow pointing to the left, which indicates that my data set is to the left. And this last one, I'm just going to put a little dash here in front of that 2 and 5/10 because I want to show you what I mean about flipping that inequality sign to the opposite. So we've got dividing by a negative 2 and 5/10. So we would want to multiply by negative 2 and 5/10. Oh, not writing very nicely. Sorry about that. Wow. Let me try this again. Okay, so we've got this negative 2 and 5/10. And we are going to multiply by negative 2 and 5/10 to get it moved to the other side. Sorry, this is not writing very nicely. So now, because we are multiplying and dividing, that leaves y by itself. And because I am multiplying by this negative 2 and 5/10, I have to flip my sign over. This now becomes less than or equal to instead of greater than or equal to. So now my sign is moved. It's y is less than or equal to. And then a negative 4 times a negative 2 and 5/10 is a positive 10. So when I create my number line, again, making sure I have at least 5 numbers. Again, this says equal to, so I'm at 10, and I want to make sure that I color that in and make it a solid circle. And it says my data set is less than that. So I would draw my arrow to the left. You may want to stop and just pause the video to get these notes written. And make sure if you have any questions about that to let me know. Okay, the other types of problems that you're going to see are problems like this, where there's multiple things happening. We've got 5 times x minus 4 is greater than a negative 3 times x plus 4. So there's lots of work that needs to be done here to get x by itself. First thing we need to do is use the distributive property to get 5 times x minus 5 times a negative 4, if you think of it that way, is negative 20. I had to use the distributive property first to get that 5 multiplied through there. Now to isolate the variable, we've got this negative 3x, so we're going to do the opposite of that, which is positive 3x, or you might think of it as adding 3x. This is going to give you 5x plus 3x, which is 8x minus 20. Is greater than, leaving just this positive 4 here. And we've got this 20 that we now need to take care of. So we've got a negative 20, the opposite of that. When it's doing that, I'm so sorry. They're just giving me hassles today. So we've got a negative 20. We're going to do the opposite of negative 20, which is a positive 20, which is going to leave us 8x is greater than 4 plus 20, which is 24. We still have that 8 attached to the x, so we need to divide that out on both sides, leaving us with x is greater than or equal to 24 divided by 8, which is 3. So drawing that on a number line, you would want to make sure Writing that on a number line, you would want to make sure that you have at least 3 digits. Excuse me, 5 numbers on your number line. So we've got on both sides of your 3, we've got x is greater than. Notice I left it an open circle because it does not say is equal to. On our other solution here, we've got x plus 10 is less than 3 times x minus 8. So we want to isolate the variable. This time I'm going to move the x to the right. It's always easier if you keep your x's in a positive mode. So I see that I have 3x on the right, which is larger than just a single x. So I'm going to move this positive x to the other side by doing a negative x or subtracting the x. It's going to leave me a positive 10 is less than 2x. 3x minus x is 2x minus 8. Notice we've got this negative 8 to get rid of, or subtracting of an 8. So we're going to add 8 to both sides. That's going to give me 18 is less than 2 times x. Dividing out that 2 is going to give me x is greater than 9, or you think that it's 9 is less than x. So when you're drawing this number line, and again, make sure that you have all of the 5 numbers. I'm going to do an open circle again because it's not equal to. It says x is greater than 9, reading it backwards. So we've got x is greater than. Now there's lots of ways that you can make sure that you have the correct solution. You could put 9 back into this problem, or a number greater than 9 into this problem. And let's say I wanted to use 10 because 10 is greater than 9. I could do, okay, I've got 10 plus 10 on this side is less than 3 times 10 minus 8, which gives me 20 is less than 30 minus 8, which is 22. 20 is less than 22. That's a true statement, and that checks out. So there's some ways that you can use your check system and double checking to make sure that your solution sets are accurate. What I'd like for you to do for class time is to do these practice problems, solve them and graph them on a number line, keeping in mind you want to get x by itself, and we will talk about these problems when you come back. Don't forget to complete the math worksheet and graph video sheet to let me know that you completed this video, and that if you have any questions to let me know. That's a good way to let me know that you understand or don't understand what's going on. Thank you and have a good day.